is Captain Chaudhari. In my series of videos on basic stability calculations, at the moment I am doing the moment of inertia. I am doing the center of pressure for the different kinds of bulkheads of regular shapes. In my previous video I had said that if you have a rectangular bulkhead, other side is water, and there is nothing in the sounding pipe, it's just filled up till the tank top, then the center of pressure is 1/3 from the bottom. But as you fill up the water level, as you fill up the sounding pipe, the COP goes up, slightly goes up. So we are going to find out, what happens to the position of center of pressure. So let there be a question like there is a bulkhead 8 meters broad and this is 6 meters in height, and ideally if just the tank top was filled up, the COP would be 2 meters above the bottom. But now it says that in this question, it says that the center of pressure is 2.4 meters from the bottom, right? So the position of COP from here is 2.4 meters. So what is the head of water in the sounding pipe? So how much is the head, right? So let's do this question. We always have the same formula. There is COP below water level is equal to moment of inertia about water level divided by wet area into depth of centroid. So let us assume that this head over here is say D, or let us say it is X. Then if this is the water level, right, if this is 2.4 here, then this distance should be 3.6 meters. So COP below water level is X plus 3.6, right? That is a COP below the water level. Now this is equal to moment of inertia about the water level. Moment of inertia about the water level will be moment of inertia about the centroid axis, that is 8 into 6 cube upon 12, and that is equal to 144 meter raised to 4, right? So that is a moment of inertia about the centroid axis. So moment of inertia about the water level would be 144, that is the moment of inertia about the centroid axis, plus AD square. A is 48 into D square. D is 3 plus X whole square. The whole thing divided by area, that is 48, plus depth of centroid would be X plus 3. Now if we assume X plus 3 equal to Y, then the equation gets simplified. It becomes Y plus 0.6 equal to 144 plus 48 Y square divided by 48 Y. So if we cross multiply, it becomes 48 Y square plus 48 into 0.6 is 28.8 Y equal to 144 plus 48 Y square. This gets cancelled, and then we have 28.8 Y equal to 144. So Y is equal to 144 divided by 28.8. This gives me Y equal to 5. So if Y is equal to 5, then X plus 3 equal to 5, because we had assumed X plus 3 equal to Y. So X is equal to 2 meters. So there is a 2 meter head above the tank top. So this is how we find out what is the head of water in the sounding pipe in case a question is given in this form, or sometimes they might ask you simply that there is water there is a head of say 3, 4 or 5 meters in the sounding pipe. Find out the position of center of pressure. Let's do one more numerical. This numerical involves combination shape. Combination shape means we know the regular shapes as rectangular shape, triangular shape and semicircle or circle. In the questions involving trapezium, let us say that there is a bulkhead which is in the form of a trapezium, and it is 3 meters over here. The height is say 6 meters, and this distance may be 8 meters, and there is a sounding pipe which is 3 meters tall, and the sounding pipe is overflowing of the liquid. I don't have to tell you the density. To find out the center of pressure, you don't need to know the density. So this is the situation. What can be done in such question? We can say that this shape is a combination of a rectangle which is 3 meters by 3 meters, 3 meters by 6 meters, there is a rectangle, and the remaining is a triangle, and 8 minus 3 is 5, so the base is 5 meters, the height is once again 6 meters, and the two shapes are connected, like liquid is common in these two shapes, and there is a sounding pipe which is 3 meters tall. So dividing the trapezium in two parts, we have a rectangle that is 3 meters by 6 meters, and we have a triangle that is 5 meters at base, and once again the height is 6 meters. There is a sounding pipe 3 meters tall and water overflowing. Now the first thing that one should do is find out the common centroid. So common centroid, that is geometric centroid below the water level, will be A1 D1 plus A2 D2 divided by A1 plus A2. Now A1 is the area, that is 18. D1 is the distance of the centroid from the water level. You can see it is 6 meters. A2, this is 5 into 6, 30 divided by 2, 15. Half base into height, that is the area, into D2, that is 4 plus 3, 7. A1 D1 plus A2 D2 divided by A1 plus A2, that is 33. 18 is the area of the rectangle and 15 is the area of triangle. So this becomes 108 plus 105 divided by 33, that is 213 divided by 33. 213 divided by 33 gives me 6.454 meters below the water level. That is the position of common centroid below the water level. So we'll write down over here 6.454. Now to find out the COP below the water level, first of all we'll write down the common formula, the same formula, that is COP below water level is equal to total moment of inertia about water level divided by total area into depth of common centroid. So let's find out the moment of inertia of rectangle about the water level and then triangle about the water level. Rectangle, what is the moment of inertia about the own axis? That is 3 into 6 cube upon 12 plus AD square. A is 18 and D is the distance from here to the water level. In respect of triangle, it is BH cube upon 36, that is 5 into 6 cube upon 36, that is the moment of inertia about this axis passing through the centroid parallel to the base, and this will be added up with AD square. A is 15, D is 4 plus 3, 7 square. So that is the total moment of inertia about the water level. And how much is this? 3 into 6 cube. that is 54 plus 30 plus 49 into 15 gives me 735. 49 into 15. So the total is 1467. So COP below the water level is equal to 1467 divided by area. Area is the total area is 18 plus 15, that is 33. Depth of common centroid is 6.454. So 1467 divided by 33 equals divided by 6.454 gives me 6.888. So you can see the position of center of pressure is slightly below the position of common centroid, 6.888 meters.